All right, thank you so much for joining our workshop today. So we're going to be learning about software engineering and a career in software engineering from our lovely host, Gotham. So I'll let him take it away.
Hey, hey everyone, welcome here on Zoom and here. Thank you, Kaylee and MJN for hosting me here. So today I'm going to talk about software engineering um, in general, and then just looking at the agenda today, we're just going to go over just about me in general, and then how I did my co-op here, and then software engineering today in the US, and then some of the tips that I could share to be successful at the workplace in the US, and then maybe for people starting out, how you want to start coding. If you were to start all over, I'm going to share my 2 cents on that. And then creating your online presence so that it appeals to hiring managers over here, and then some resources to help you along the way, and finally we'll wrap it up with some QA. Okay, so about me, right? So I'm at Northeastern. I'm a master's student doing in the SES program in the MGen. What do I like? I like biking. I like hiking. I like building cool APIs because I'm a software engineer. I love quotes. That's one of my favorite quotes from Steve Jobs. Some of my background is I did a BS in computer science in India, and then my experience is a software engineer for 2 years. What I usually do, what I did in my job was working on the integration. So I was mainly on the back end, building microservices, building their APIs. In Kotlin, it's a new language. It's a JVM based language, and Java, and a bunch of cloud native tech stack. And then just so recently, 3 months ago, I began a summer internship, as a grad intern at Pegasystems. It's right in Cambridge. So it was a hybrid internship. So I was here and sort of biking to office, and it was great. I'll talk about that later. Yeah, feel free to connect with me on LinkedIn. I started coding somewhere in 2012. I just took a very basic Visual Basic class when I was in middle school, sort of building small text boxes and widgets in Visual Basic, and then that's sort of how I began my programming journey. And then I followed that up with C++ in high school, building some cool projects there, and backend stuff. And then my undergraduate was in computer science. I took a lot of high level courses like compiler design, data structures, machine learning, and something like that. Won a lot of hackathons that were hosted in the college, and that's sort of how I built my love for computer science and programming. And then right after college and beyond, I've started working as a full-time software engineer in India. Yeah, as I said, just building microservices and APIs as a backend Java developer in a Scrum team. And then I moved here last year for grad school, and yeah, landed my first co-op in the US in the summer of 23. That's a bit about me, and just to go over the final slide about me, I promise, before we get to the good stuff. So what I exactly did in my co-op, right? So it was a 3-month internship over the summer. Started off with reviewing my projects and goals, what I'd be doing for the summer. So essentially here it's all about good communication and knowing what you're going to do upfront even before you're going to do it. So it's a good review of what's going to happen throughout the summer. And then the first thing I ever did was this event called Pega World. So it's the company's annual tech conference in Vegas. So I sort of built a demo application with other engineers and POs in the company that was demoed live at Vegas. That was pretty cool. And then some other stuff that I did mainly at the work side was again diving back into those microservices in Java and Kotlin. So a lot of refactoring of those APIs, building new APIs, and then deploying those and sort of seeing in the apps itself how the app or the microservices affecting the overall architecture of the applications, and how users are sort of leveraging the benefits of those refactoring. Yeah, of course, software engineering, you cannot avoid bugs. So did some bugs in support for the team. and then built new features. So it's like apart from refactoring APIs, sort of like built new features as well. So like there was like a cluster of microservices that are like connecting the whole platform. So sort of built new features to like make two microservices talk to each other using like post REST calls and HTTP. Yeah, and then like there was like an intern hackathon that happened towards the late stage of the co-op where we had to like have a theme. So that the theme was improving the hybrid workplace at Pega, like worldwide. And we sort of like built an app. It was called like a virtual water cooler. So we sort of integrated like an app native to the tech stack there, sort of talking to WebEx, essentially like pairing you up with someone in the company who doesn't work with you directly through your interests, and using like generative AI to like schedule a meeting on the fly and sort of create new bonds. So that's something that we built as an intern team over 3 days, and we won that. And then yeah, as as a result of that, we had like lunch with the CEO, and then wrap it off. Like I had like a final presentation with the team and about my whole work on the summer. So that was pretty much it. Now I'll get to the good stuff. Yeah, I follow a lot of tech people online, and this is one of my favorite people. He's Kevin. He's a senior engineer at Google. And the first thing that comes to software engineering when someone talks about it is code, but it's really not code. It's basically about the software and like how that software you build is affecting the clients and the people that are using it. So like if software, I mean, if users take your software for granted, then it's good software. So that's like some code that I just picked up. So getting into software engineering today. Yeah, so specializations, right? Like as of 2022, like the number of professional software engineers in the US is like 4.4 million. That's crazy. And if I'm assuming everyone here wants to be one, so if you want to be one, then like what do you do, right? It's not just some field that you can just like dive straight headfirst into without knowing what you're going to be specializing in and what you're going to be working on for the rest of your career if you choose to be in one. So there's like a lot of specializations here. I'm going to start with security. So like security is like you're going to be making sure like as an organization in the company, making sure that this code that you write and everyone in the company writes is like secure. You don't want any vulnerabilities. You don't want like external people who are like using that software to like exploit anything in that code. So if you've heard about like the Log4j vulnerability, it was like a huge thing that affected so many companies like all over the world. So security is one field that you can get into, and then like these are kind of like the core fields that are available today. Like I just went by like the top few ones, and then like full stack, right? So like that's something so vital right now. So you're like backend is something that people do. I mean, like you can specialize like as a backend developer, something like what I did, but then full stack is something that you cannot avoid. I feel like it's something that's so vital. You can't just like build like your backend and expect like other engineers to like take over and work on the front end for you. So like unavoidably you're going to be working on the front end. You're going to be like using React and other frameworks that are so popular today, heard I mean like all over right now. So that's full stack. So you're going to be like building your backend and making sure what you built is working out through like an interactive front end. And then DevOps is something that's trending as well. So like you build your software and then you make sure that it's deployed as well. So you're responsible for like not just like building a software. So if you're like looking at like a service or just like a microservice, if we like look at a microservice, right, you build it out separately, but then what you do is like you deploy it in a cluster that's also hosted, I mean that hosts like a bunch of other services and a bunch of other platforms. So essentially what you do as a DevOps engineer is not only do you ensure that the code that you build is like meeting the like standards of the company and like just good code practices, you also ensure that it's deployed in the environment that you choose, and then you make sure that it's integrated well with the other services or the other platforms that you're building out as well. So that's DevOps. You not only build out, but you also like deploy it. And you as an engineer or a team are responsible for that. And that's primarily what goes there. And then cloud and infra, right? Cloud, if is something that's like so vital today. And like every on-prem, so on-prem is something like you have your servers and everything set up like on premise, so like somewhere like a physical location, right? But then that's like completely being moved away right now. So like everyone's moving to the cloud because like you do not have to manage your infrastructure, right? So if you look at AWS, you can just like create a server on the fly and then just like do some work on it and just like tear it down like in a minute. So cloud and infrastructure is something that's like really booming and something so vital today in the software engineering realm. So that's another core area that people are looking for right now. And then back end, right? Like that, as I said, it's like building out applications and integrations basically. So you can think of back end as something like making a call, right? So what I say, like if you're using like a payment gateway on an application, right, it's not going to be hosted like independently. So when you choose to like shop on an e-commerce website, it's going to integrate with like a third party payment gateway. So that's kind of like backend. So you sort of make like a REST call over the network to another service and then like talk to that service through like a standard protocol like HTTP, and then you get that response back, and then you're sort of responsible for like building out a solution that can be secure and like that has like acceptable response times. And then QA is another huge thing. It's like quality assurance. So like there are people in the org that specialize in making sure that your code is like of the optimal quality. So they're gonna like, you write your code, you put it out, and then like a tester is gonna like, come at you and then say, you know what, this is not good enough. It's gonna create a lot of bugs. Just like take it back and just like work on it again. So QA is a huge area where, like you have these people who are gonna like know more than you, right? So you as an engineer are gonna like know the use cases that you design and like the edge cases that you think of, but then a QA person is like specialized to like find out those exact test cases that are gonna like break your code or like something that's so out of the blue, but that's something so vital to like a good client experience. So QA is its own thing. So you can essentially, you got to be so good that you can like test out code and you can like understand the scenarios of someone else's feature or software, and then sort of say like, hey, this is not how it's supposed to work, or this is like something that could potentially break your code, like you should fix it now before someone like actually who's paying for it uses it. And then site reliability is kind of closely linked to cloud engineering. So what that does is like you're going to be responsible for maintaining outages. So outages is something that happen all the time, right? So even AWS like has outages like kind of frequently, but then they fix it pretty quick. So let's say like you have your solution hosted on the cloud, and then that cloud, I mean like the cloud itself or like your service kind of comes down, like what do you do, right? So you gotta make sure that you have the right logs and like right traces so that you can find out what's going wrong. So like site reliability is sort of making sure that your infrastructure is all in one piece. So cloud is like you build your infrastructure, and then site reliability is like making sure that that infrastructure stays up, and like if it comes down, like what do you do to bring it up like as quick as possible? So because like each second you lose is like money down, right? So I sort of put these all like in like overlapping Venn diagrams because yeah, they're all related. You're never going to be hired for just like one thing and be expected to do just one thing. So like if you're hired as like a backend engineer, there's no way you're just going to be like, I'm here to just build like, an API and that's all I do. And if someone gives you a task in like front end, or if someone tells you to like, like deploy it, you can't just say that, that's not something I work on. So like, like just like delegate that to someone else. So it's all going to be like interrelated. Like just giving an example, personally, I was working on like backend, cloud, DevOps, and security sometimes. So it's like it's all interconnected. You are going to specialize in one thing, sure, but then you will always have tasks that somehow just like overlap and somehow go in between. So that's like a quick overview of how software engineering looks like and like how you can specialize in it. Now I'm going to share like what you need to do to like succeed, or like just like good starter tips about working in the US. So like you have an idea of what you want to do, like you have a specialization in mind, and like now you want to work. I mean, you will land an internship or you land a co-op, and then like now you want to make sure that you leave a good impression and you like sort of do the work that you're hired to do. So how do you do that, right? There's so many things that can help you along the way. One thing is like communicate. So I emphasize that so much because you have to communicate here and in general, like in the field, because like you are going to be given tasks that you have no idea how to do for sure. That's something that happens so often here. uh and then like if you're stuck days on end just like trying to figure it out yourself, or like not knowing what's going on, and then you just like in the stand up you will be like I'm just like working on it, and you do not give visibility into like what's going on, then it's just going to look bad on you, and it's people aren't going to help you unless they know what's going on with you. So communicating what's going on so often is like so essential here, not just about working. It's just like about collaborating with others and like asking for feedback, and and just making sure that the tasks that you're assigned or like the things that you're working on are just like going along the way. And that's communication. And then like leverage mentorship, because you'll always be assigned like on a co-op, whatever it is, 3 months, 6 months, 8 months. You're like a junior engineer, right? You're barely a junior engineer, so you're always going to be assigned like a mentor or like a buddy to help you along in that journey. So essentially like leverage the mentor as much as possible, ask questions, take feedback about your code, and then sort of just like keep communicating and like find ways to like take more work, or just like ask something that is something that you're unsure of, something that's like complex. Just ask. People are always here to help you out. And then write good code is something that's a cliche, but then I sort of striked it out because it's more about solving problems. Like you are writing good code, that's a given, because like they hired you. I mean, if you're there, then you're going to write good code. They know that. But it's about solving problems, right? Like, so you want to essentially like, um, how do I put this? So yeah, when you're like presenting your software to a client, you're not going to say like, this is like really fast, or like this is like we use this latest tech stack, and then we build this on like Kotlin and it's like super fast, and like no one cares about that. Like all they care about is like what the problem is and like how you solve it, or like what's your like take on solving it. Like did you like use like an innovative way, or like did you solve something for a problem that's out there and like someone else is not. So it's all about like like how good your software is to the clients that are using it. So essentially that boils down to like looking at it at a broader level. So like software engineers, like in at least like junior engineers, or like when I started out, I initially tended to like gravitate towards like how good my code was, and like I was only thinking about it from like a narrow perspective, because like that's how you start out. You can't blame yourself for that. But then it sort of essentially works at like talking to your POs and talking with your managers and seeing like what the clients want, or like what are prospective clients looking for, and then how can you build out like a solution that solves that problem in like the most optimal way possible. So it's all about the problems, and it's all about solving them. It's not about writing great code. That's kind of inherent. And then what do I say? Explore, right? So explore is so essential, because you're going to be on a limited time. You have like 3 months, you have 6 months. You're not going to be so you're going to be expected to do a lot, I would say, but then you do not have a lot of time to sort of, like take it in your own pace. Of course, the code is going to be massive. It's not going to be something that you've seen before, because like production code is like, like 10,000, 20,000, or even like a million lines on a project. So you're never going to be know exactly how everything works, but then you have to like start off somewhere. So like, I would like how I usually go about is just like talking to my like senior engineers in the team, and like just like cloning the repo, and then like sort of putting debug points at like entry levels, and then seeing like how the code works, and then like sort of ask questions about like, why is it doing that, or like what's it like, why is it supposed to do that? So sort of exploring the code and then sort of asking questions about it, and then like putting out tasks and like sort of smashing them like very early on in the internship is sort of vital. Yeah, and then feedbacks, right? Like, do not hesitate to like ask for feedback, or like even when feedbacks, yeah, I mean, like just look out for feedback, right? Your manager is probably gonna like sync up with you anyway, but then like even if you feel like there's something that you need feedback on, just like reach out to people. They're gonna really give you some amazing feedback, and they're gonna tell you like, you're doing this, you're like, yeah, and just like take it all in a positive sense, and then like have some fun, right? It's like 6 months or 3 months, it's going to be like hectic kind of, but then just remember to like have some fun. That's just like an overview of some success tips. And then the process, right? So like if you're starting out and what do you want to do? Like you're just like seeing all these courses, or you're seeing all these tutorials, and you're like, where do I begin? So I would say like there are 3 stages. One is like the exploratory phase, and then that has 2 parts. That's like learning a language and data structures in parallel. So like pick a language, take your time, because it's going to be something that you're going to be using for like, like all your work and beyond. So really take the time to understand the different languages and like how they differ from each other. So if you're picking something like Java, then it's like strongly typed, and it has all these types and return types and stuff like that. And then if you're picking something like dynamic like Python, then you're going to have like a lot more cleaner code, but then you're really going to have to spend some time into understanding why it's so terse and stuff like that. So I would say like really take your time to understand what language you want to pick and like how you go about that, because that's really vital. Because I remember like starting out with like C++ and then like not wanting to move away from it because I was so used to it. And then like I went to Java, and then I was like, wow, I'm never going to use C++ in my life again. And then I looked at Python and I liked it, but then I sort of like how Java works now. So I like it to be not too concise or like not too elaborate as well. So that's just like the sweet spot that I like. So that's a personal choice, but then be sure to find your personal choice, something like that. And then like data structures and algorithms, right? That's like the most crucial thing ever. You're gonna be like using that throughout your life as an engineer, like to sort of understand how structures are built and how programming works in general. So like really this is like the crux of how you like start programming and building the intuition to like solve problems, right? It's about like like your problem solving skills and your interest for that. So like do not like lose I mean like do not be discouraged if you're like not able to solve the complex problems and stuff like that. How do I go about starting data structures today? Is like just follow NeetCode, I would say. So like I'm going to share some resources towards the end, but like NeetCode was something that I wish I had when I started out, because it lays out the entire roadmap for like like learning data structures, right? So you start with arrays, and then you start with the strings, and then you move on to more complex things like sliding window, and then you go to like recursion, and then you go to dynamic programming, and then you go towards graphs and like other things like trees and binary trees, so heaps and stuff. So essentially that roadmap is how you uh, sort of go from like the most simplest concepts to like the most complex things. So essentially follow that roadmap. That's like really how you get into good practices and like building those core concepts that you always need. um, yeah, so like there's like a NeetCode 150 of like the top problems and like the most common problems that you ever are going to encounter. But then I would like highly recommend using like the NeetCode 333, because like that's like the 333 of the problems that he solved. And like those are like you have like a wide array of problems, right? You just don't have those like medium or hard problems like right away. And then when you like just dive into that, you're going to be like, oh, I can't solve it, and like I'm not a good programmer or whatever. But then start with those easy problems and then just like work your way through. So that's like I would highly recommend going over those 300 plus problems. And then once you have like a language that like you have a tool that you can program with, and then you have like a good understanding of like the basic data structures and like some algos that you need, then you gotta pick one of those specializations that I talked about, right? So how do you like essentially do that? I would say it's like a combination of um, just just like your intuition and like exploration again, because like you're gonna be choosing something that uh, you're going to be like essentially doing for like a good part of your like early career. So you want to pick something that you're good at and you like, and if something does not work your way in that, you like being challenged, and you like sort of exploring it more and sort of giving it more time and seeing how it goes. So like I would say yeah, like essentially start building out like small scale projects like on GitHub and like following free code camp. So like there's like a resource called free code camp. It's sort of like is your go-to resource. It's a free resource on YouTube. So you sort of just like type that on YouTube and just say like some topic space free code camp, and then you have like a 6 hour or 10 hour tutorial explaining those things, and it's like a hands-on coding experience. So I would say like take your time to like figure that out. But if I would to give you a place to start, it would be like start with backend, because it's slightly like more enjoyable and it's slightly less frustrating because you know when you start out building like backend APIs and stuff, you have like a purpose. Like let's say like you want to build an API to like have a post communication, like so you just want to talk to an external service, get its response in JSON, and then sort of just like use it in your code, right? So that's sort of straightforward. You just need to be able to like know the right libraries and the right frameworks, and you sort of like have like a working thing in your mind, and you can just sort of translate that to code pretty easily. But then when it goes to like front end, you spend like hours on end just like figuring out like why the margin's broken or like why the padding's messed up. So I would say like start with backend and then like move your way up if that's something you want, and then like if you're like trying to specialize in backend, then I would say just like go to cloud and explore AWS and GCP and things like that. And then it's sort of like it goes in parallel with like your personal projects, right? As I talked about. So when you know you want to do something, you have to like put out projects out there that highlight, you know, that's something that significant you've done in that specialization. So it's like data structures and algorithms is knowledge that you need for sure, yes, but then like how do you translate that into like something that people care about, right? You can't just highlight like data structures and algorithms on your resume, because that's something that you are expected to know. It's not something that highlights like an experience or a project. So you got to build something with the knowledge of the things that you picked up in DSA, and then like build your projects out. And then once you have those out of your way, and then like at this point you know a language, you know like data structures, you know what you're going to specialize in, and then you know you have like a decent portfolio of projects that you're proud of and you can highlight them on like GitHub or whatever. Then I would say like there are 4 things that kind of help, that do help. Like one is like open source. Like open source is something that's so essential these days as like a software engineer. So like uh, how do you put trust in someone uh, who's looking out to like potentially hire you, that you know you're good? So that's essentially through open source. So like you say that, yeah, I mean like it kind of emulates the working model very closely as well. So when you say you have when you work on open source, so like it's like there are open source projects, right? Like what are they? So it's like open code about a project that anyone's free to work on, and then you have specific set of people that own that software or code, and then they sort of review that code and sort of and that review process is just them, but anyone can write the code if it's legit, and they'll have a look at it, add some comments, and then say, you know, like, hey, I'm going to merge this code because it looks good. So that's like by building a portfolio that centers around open source, you can like prove to people that, you know, you're like a legit programmer, and people do like take you seriously because like you've contributed to like multiple like projects that people are like really interested in, and like people actually like look at, and then you have your like you have your code there. So that's something that really stands out. And then, of course, doing an internship or co-op sort of like solidifies that you know what you're doing and you like kind of specialize in that. And then I would say, like, you're here in your master's program, pick a few 6,000 and 7,000 series courses. If you know what you're doing and if you like know what you want to do, and then like picking those courses sort of like really help you out, right? Because you're going to be building a project and all those assignments sort of helps along the way. And then, yeah, of course, professional experience kind of like a full time, and then it kind of encompasses internships. So that's like a overview of how you want to start. Um, and then, yeah, online presence, right? Like, what do I mean by that? So it's just not about your resume these days. It's about like it's like a combination of all four of these things. So yeah, your resume, yeah, sure, you need one. You're gonna be something. I mean, it's something that everyone is gonna look at. That's the first thing that people are gonna look at. And then how do you go about that is like there's something called ATS here. So like that's the application tracking software or system. What that essentially does is it sort of acts like a filter. So it filters out like weak applicants even before it reaches like the recruiter, and then like a human's not even going to like look at it if it doesn't get past the ATS. So you want to make sure that you build a resume that filters through the ATS. And how do you do that is I'll get to that. But then essentially what I would recommend is using this free software called Resume Worded. That's like a tool that a lot of people use to sort of why is it so good is it sort of quantifies your resume on a scale of 100. So let's say you just like have a resume right now, and if you want to assess how it's going to do when you like get it out there, so you just like upload it there, and then it's going to quantify your score to something. So let's say you get 80. That's like an average score. And then it's not just going to give you out a score, it's going to tell you like it's going to like tell you like what's wrong with it and like why you have like a lower score. So it's going to it has like a few key parameters, like it's going to tell you that you have to have quantifiable results on your accomplishments. So it's not about just like saying that for example, so you built an API, right? So you're just not going to say that I built an API using Kotlin and it works on a tech stack so and so, and then this is it. So that's something that you did, but how is it helping the company? Something. So you have to quantify the accomplishment. So you have to like reword it in such a way with action verbs. So let's say you built an API in a new service which enhanced or like bettered the response time by like 50%. Then that's something that it's more eye-catching, and that's something that is that you made an impact and you know how you made an impact. So that's pretty important in a resume. So essentially that it boils down to how well you quantify your accomplishments, how succinctly you can sort of put your points out there. So it's not going to be too long, and it's going to be about like the strength of your action verbs. So you have to use like strong action verbs throughout your resume. You can't just use something basic like helped. It has to be something like maybe enhanced or like augmented or something like that. Those are strong action verbs I can just think of. So that's your resume. That's like one part of it. And then the other part is like LinkedIn, right? So that's like I mean, I was like juggling between like resume and LinkedIn, but I would maybe say like LinkedIn is probably more important than the resume itself, because that's like the first thing that they look at, because it's also going to be on your resume short. But your online presence is like so vital here, and like highlighting your skills and like your experience on your LinkedIn is like so crucial. How do you do that? It's like anytime you have an experience, so like you have like you want to add to LinkedIn, so don't just like put it out saying that you had like an experience like of 2 years, and then like that's it. Like you gotta sort of break it down into like what you did. So you have to like say what were your technical contributions. It's sort of like your resume, but then you can add more. So this is your chance to like sort of add stuff not in the resume, but like I mean also in the resume, but then you have like an opportunity to like be more expressive and have more like be more verbose about it. So really take your time to like see how well you can do that, and sort of highlight your technical contributions in a bulleted format, and then highlight like your leadership skills as well, like how you helped others in the company do their work better, or like how you enhance the people around you. So it's all about that. It's not just about your work, it's about how you help people around you and in your team. So really like take the time to like think about how you did that in your previous work experience, or like your new work experience, whatever. And then yeah, that's it about that. And then like essentially like when you're done with an experience, like reach out to the people that you worked with and like ask for a recommendation, right? So like ask for endorsements on the tech stack that you worked on, ask for recommendations about how you made an impact and what you did, and that's like work summer or like whenever you did it, and sort of highlight that on your like resume. And then portfolio side, so this is something that like so recently came up. It was something that mainly people in the front end realm would use, because like they have the skills to like build out like like a really good looking website that highlights who they are and what they do with like some snazzy UI and stuff. But this is something that like I would say anyone in like software engineering needs right now. So you can't just like get away by saying that, you know, you're not like an UI developer, so like I don't need one. So this is something that also shows that, I mean, it sort of sets you apart. It's all about setting yourself out in the crowd, from the crowd, right? So this is like a great way to do that. So like putting this website on your resume like really like augments your chances of getting called back. So really take the time to do that. And then like GitHub, right? So this is like your um, chance to like show how technically versed you are. So it's not just about putting like a few languages and a few frameworks on your resume. It's about how you leverage those frameworks and resumes to like build cool things that people are interested in, or help people, or like something like that. So this GitHub is so essential, and it sort of piggybacks to the open source stuff that I talked about earlier. So like this is how people know, right? So you're having your GitHub profile on your you have your GitHub profile on your resume, and then that sort of highlights to people. They're going to like look at it, and then they're going to see like, okay, how did this person contribute to the open source? How did this person sort of help the community out by, you know, doing stuff on their time, and then sort of showcasing your projects as well. So when you say you're good at this, or when you say you have these skills and like these frameworks that you really like are good in, and this is the place to like sort of highlight that, yeah, you did some work in that, and this project is like really cool, and you sort of highlighted through that. So these are the 4 pillars of your online presence, and really I would say all of them are like really important. But then if you want to pick like what you want to start with, it's going to be like the LinkedIn and the resume for sure. You can probably like get to the GitHub once you have like some like decent experience slash projects slash coursework that sort of helped you build something that you can actually put on the internet. So that's the online presence part. Then resources at Northeastern. So like what I leveraged at Northeastern to sort of help me out and succeed, right? So these are some of the courseworks that I'm like very biased. So like I'm gonna give you courses that I personally took, and then I do not know about the rest because I personally did not take them. But these are some of the courses that I took and I found like really helpful. One was the enterprise software design course in the CSOIE bracket. That's like a really challenging and fun course. It sort of helps you build cool like Java applications on Spring Boot, and like sort of helps you like build like Java like enterprise applications on the back end, and like sort of have it integrated with like a Hibernate database and stuff like that. So if that's something that like tickles your fancy, then you should probably take that. CSY 6225 is like network structures and cloud computing. It's one of the most fabled courses here, if you've heard of it. It's like a very challenging, I mean, it's probably the most challenging course in like CSY, and it's something that students from the Curie College wish they had. So that's I'm like taking it right now, but I can already say like it's like an amazing course from what I've heard and what I'm like experiencing right now. And then 6205 is like the program structures and algorithms. So that's like essentially like a DSA boot camp at the uni that you can take and sort of help you out on your journey. And then clubs, right? So I would highly recommend like joining or taking part in events that are hosted by these two clubs. I haven't personally like gone to much of the Husky Sisters code myself, but I heard it's like a great place to sort of network with people who are like similar to you, and like who they also host like a lot of like lead code workshops. So like if that's something that you're like looking to start, or like if you wanna like solve lead code problems with people who you don't know and you just want to like make new friends, then that's like a great place to go. And then competitive programming club is like a little more on the extreme side. So I do like visit that sometimes, and it's more about like ICPC. So that's like you want to like build like really competitive coding. So like that's if you're like interested in taking part in like competitive programming competitions and like sort of building out your like critical thinking on like some extremely complicated problems, I would like recommend visiting their meetings as well. I think they host like once every 2 weeks or something like that. So you can check that out. And then the coding resources that I talked about is like NeetCode is the one that I highly recommend to start out with. Lay out your roadmap and sort of work on it every day. And then you're sort of bound to be on that journey to be a better programmer. And then Free Core Camp is something that I use personally to like just like look at quick YouTube videos on something that I feel like I need help with. And then Resume Guide, yeah, sure. Like use Career Studio. It's like a place at like Northeastern. I think it's Stearns Hall, but I'm not sure. But that's like a place where you can go with your resume and sort of like ask for feedback from like a one-to-one mentorship. That sort of helped me out like last year, like I would say like fall 22, when I used to go and like sort of just take feedback on my resume. It's like they gave me some really great pointers about like what I need to do better. And then the resume worded is like a quantifiable ATS filters system that you can use to like sort of improve your resume. I would say like get a score over 94. Like that's the threshold that they set as well. And that's something that takes a bit of effort, but then it's definitely doable. And then just like some books that I kind of use right now is Cracking the Coding Interview is like really great resource to sort of understanding how you can beat coding interviews, and sort of just builds your intuition about like how you're supposed to interview in like for tech. And then System Design Interview is something on the extreme end, which I think like now a lot of software engineering roles, even at the entry level, demand like a good system design experience. I mean, not experience, but like knowledge. So that book sort of helps you like build a high level overview of how system design works, and like how you build more scalable applications, and not just like something that you use for like a single user, but like multiple, like like potentially thousands or millions of users. Like how do you start thinking when you need to design something like that? So that's going to help you out there. Yeah.
Okay, I think we'll end the session there. Thank you so much, everyone who joined in person and online. You have Gotham's LinkedIn, so if you do have any questions, I'm sure you can bother him on there and he'll be happy to answer anything that might come to mind. And so yeah, just thank you, everyone, and thank you so much for
Thank
coming
you.
today and sharing your wisdom with everyone.
Thank you.